Okay, so let's continue with an introduction to R, and now we're going to take a look at an example. This example deals with GPAs, high school GPAs and college GPAs, and we like to understand the relationships between the two. Now, a real-life scenario where this might be of interest is with respect to college admissions, where the admissions office wants to decide who should they let into their university and who should they maybe perhaps not. And so what they might do, at least at an undergraduate level, is look at how did a student do at the high school level and maybe even try to use that to predict how they would do at the college level. One way to look at how students did at the high school level is to focus on their GPAs. And so that's what we're going to do here. So let's suppose that we had a random sample of 20 college students at our particular university, where we got their college GPAs and also we had their high school GPAs. And so what the first thing that we need to do is take a look at the data. So the data itself is stored in a plain, wrong file. It's stored in a plain ASCII text file that you see here, gpa.txt. And I have this open up in Notepad right now. What we need to do is transfer this data into R, or read it in, you could say. And to do that, we're going to use a function called read.table, because as what we saw here, essentially the data is almost like in a table format. You know, we have rows, we have columns. So we're going to use read.table, that function, to read that data into R. Now, the actual physical location of where that data is located is on my hard drive. In particular, it's my C drive. It's in the data folder. And again, it's called gpa.txt. Now, to indicate the actual address then within this function, notice how I use 2 slashes here, where normally we would just typically see 1. And that's because a single slash has a different meaning. Now, at the very top of the file, let's take a look at the file again, we can see that we have the variable names. So I can specify the argument header equal true as its value to say, yes, indeed, I have the variable names at the very top of the file. And notice how basically spaces separate the different variable names and also the variable values. And so I can use SEP for separator equal, and if I want to, I could put quote, space, end quote, but actually, you need to even put a space there. It still works. So I'm going to put all this information then into GPA. So let's go ahead and run this code. And if I type GPA, I can see now the data set is inside of R. It's an object called GPA. So if we take a look at the data here, the first student that we had sampled had a GPA of 3.04 in high school and a college GPA of 3.1. The last student had a 2.88 high school GPA with a college GPA of 2.6. So there's our data. Now, there are other functions that can be used to get the data into R. So very often we will be working with a data set that is comma delimited. So rather than spaces that separated the variable names and the actual variable values, now we have commas. So it's a comma delimited format. And in fact, if you were just to simply click on a comma delimited file on your computer, the default, at least in Windows, is to open it up. Let me pull that window over here. Sorry about that. The default way is to open it up in Excel. Okay. And so let's say that I had the data in this format instead. Rather than, you could use read.table, where you put a comma there. But what's more simple to do is use read.csv and then just put the file name in there. You can specify, just to be formal, the full location as well. And that will read in the data. Okay. Now, if you're working with a particular folder or directory on your computer a lot, very often, rather than putting that full directory structure in there, it's often easier just to say, let's set WD, meaning set working directory, and then as an argument dir for directory, you put in where the actual folder that you're working with. Okay. There's other ways too to specify particular folders and stuff, but this is the one that I typically use. Okay. So we got the data in R. Let's take a closer look at the data. I'm going to make it back over here to R. Now, there's a function in R called names. And names is very useful to understand the names of content within an object. So if I say names GPA, look what happens. It tells me I have two variables, high school GPA and college GPA. And this is useful because if I were to specify GPA $HS.GPA, look what's going to happen. It's essentially going to pull out all the high school GPAs from the GPA data set. I could do the same thing with college GPA as well. Remember, R is case sensitive. And there we go. So that $ is used a lot in R, where when objects have names inside of it, if you want to pull out a particular named part of that object, use the $. Now in R's terminology here, this GPA that we see here, I have called it a data set because it is a data set. But in R's terminology, this is actually referred to as a data frame. You'll hear me use that phrase a lot, data frame. It's because you can kind of think of it as a frame of data. Okay, so we looked at how to pull out like the high school GPAs using that $ syntax. Here's another way that you can pull specific information out of this GPA data frame. You can specify particular rows and columns to pull information out. So if I say GPA left bracket 1, 1 end bracket, what that's going to do is pull out row 1, column 1. If I did 1, 2 instead, we have row 1, column 2 of our data frame. So R works with a row structure first and then a column structure second when you use this kind of syntax. For those of you who've had like a matrix algebra class, again, this looks very similar to what you would have seen in that particular setting where you specify a particular row and column to access certain parts of a matrix. Same concept here. Now look what happens though if I don't specify a row number at all, but I say I want column 1. What that's going to give me is all of column 1. Again, the high school GPAs. Here's the college GPAs. Maybe I just want, let's say, some of the college GPAs. So let's say I want, the first one, second one, and third one. And I want, again, all the college GPAs. So notice how I combine together 1, 2, and 3. And now I just get the first 3 college GPAs. Another way I could have done that is this way. 1, 3. That colon in R often represents the word to, as in TO. And there we go. And let's look at another way to access part of the data frame. Rather than specifying a column number, what I can do is actually specify the column name. So I can say GPA bracket, comma, quote, high school or HS.GPA, end quote, and bracket. And that's how I pull out all the high school GPAs. So you can see there are multiple ways that you can pull information out of a data frame. A simple question that I might give on a test then is, give me 3 different ways that you could, let's say, show me all the high school GPA's value of the GPA data frame. Rather than using the GPA data frame, I might have some other data set instead. Okay, so let's see here. Again, I'm just looking at my notes. How about if I want to summarize the information that's in the GPA data frame? Well, I can use the function called summary. Summary GPA. And here we have some summary statistics such as a mean, a median, a maximum value, and so on. So that can be useful. Okay, so we're on the kind of the middle of page 3 right now in the notes. I have some comments or notes here. So if we take a look at my program here, I often start lines with a pound sign. What a pound sign or hashtag means in R is that you are going to begin a line with a comment. So in other words, it's not actual, let's say, a function code that you want to execute. Rather than when R sees a pound sign being used, it basically simply says, okay, I'm just going to display what's in there. I'm not going to actually look for functions to run. So let's say that I highlight this original set of code again and run it. So you can see that R then transferred the comment into, tin transferred the comment into R, and then also then ran then read.table. Note that the default in tin-R is not actually to transfer the comment itself. Rather, I've changed some of the options in tin-R to actually show it. And if you ever need to know how to do that, just ask. Okay, let's see now. Let me actually go into the notes here. So we're on page 4 now. What about data? What about data that is in an Excel file? Can you read that into R? Well, yes, you can. Do you want to? Probably not. The reason why I say that is because often there can be problems with working with Excel due to 32-bit Excel, 64-bit Excel. Note that R has 32-bit, 64-bit as well. Also dealing with a .xls file versus a .xlsx file. It just ends up being more trouble than what it's worth. Now, if you do have an Excel file that has data in it, it's very easy to save it as a comma delimited file instead. And that's what typically most people do when they're working with R. However, if you're interested in still working with Excel files, you will need to actually download R package, and there's a number of different R packages out there that will allow you to do it. But at least in this class, I will not work with Excel files at all. Well, what about, let's say you want to get some information out of R. Maybe you've created you've done some calculations. Maybe you've created a data frame itself that you want to get out of R. Well, there are functions like write.table and write.csv that will allow you to do that. And those examples are in my program. Okay, so we have some more comments that I've already talked about here. Let's go ahead and move on to the bottom of page 5. Now again, originally with this GPA data set, it said our purpose was to understand the relationship between high school and college GPA. One way to do that is to plot the data. So let's look at what's called a scatter plot, which in other words is going to plot these pairs of high school and college GPA values on a grid. So let me actually get back here to 10. And to do a scatter plot, simply use the plot function, where on my x-axis, I'm going to pull the high school GPAs out of the GPA data frame and plot those. On my y-axis, I'm going to put all the college GPAs. So let me go ahead and run that. And what will happen, unfortunately this will open up in a different monitor, is that we have a graphics window open up. That's opened up by R. And this is what the plot looks like. So for example here, we see this circle here. This represents an individual who had a high school GPA of 4.32 and a corresponding college GPA of 3.7. Now for those of you who maybe are not from the US, you might be wondering, how can you have a GPA greater than 4.0? And the reason is because at Many high schools, they offer what are called advanced placement courses, which essentially are essentially college courses. And to get it, if you got an A in one of those courses, that would correspond to a 5 for GPA for that particular course. So that's why high school students in the U.S. can get higher than a 4.0 GPA. And so if we take a look at this plot here, we can see that there seems to be a kind of an upward trend, meaning as the high school GPAs go up, so do the college GPAs. And I think generally speaking, this is what we would expect to have happen. We will look at this data more later. Okay. But I guess first of all, what we should do, is that let's talk about how we can make this plot look better. And all your plots that you do in my course, I expect you to do this and don't just go with the default of what a plot would be produced. So we're going to use the plot function once again to make the plot look better. We're going to put again high school GPAs on the x-axis, college GPAs on the y-axis. Let's put some nice titles on the x and y axes. And the way to do that is with the xlab and ylab arguments. We're going to put a title on the plot as well, so we use the main argument to do that. And let's control the x-axis limits. Let's let the x-axis limit be from 0 to 4.5. And so notice how we combine together 0 and 4.5. And if we're going to do that for the x-axis limits, let's also do that for the y-axis limits. The color of the plotting point, let's use red. You can pretty much use any standard color name associated with a color. The plotting character, that's what PCH stands for, is 1. This is actually the default. There are a number of plotting characters that are made available to you in R, and they each have a corresponding number. I'll show you what those are shortly. CEX corresponds to is how big do you want the plotting points to be. The default value is 1. If I were to use 2, that means the plotting points will be twice as large as normal. And lastly, before I do anything at all in my plot, in terms of like plotting the data, let's actually put some grid lines in the plot. And the color of the grid lines is going to be gray. And the line type, LTY, is going to be dotted. So let's go ahead and execute that code. This plot then is going to go to the same graphics window that we just had. Let me pull it up. And there we go. Now we got a better looking plot than what we had previously. Okay. Let me get back here into my notes. Okay, so if you want to know more about all the different colors that are out there and their corresponding names, you can run the colors function, and that will give you a list. I think there's like 600 and some different colors. You can also go to this website here and actually see a plot of all the colors. In terms of actual plotting characters, 1 is the default plotting characters, an open circle, 2 is a triangle, and so on. And so you have 25 different plotting characters to choose from. There's ways to get other plotting characters too, but these are the ones that are made available to you by default. Note that it is better to use like an open circle rather than a closed circle when plotting, because if you have, let's say, 2 points that are close together and they're basically overlapping, you can typically see the overlap with an open plotting point than what's called a closed plotting point. So that's why plotting point 1 is better than plotting point 16. In terms of line types, the default that are available to you, there are 6. You can refer to them by number, or you can refer to them by the actual name itself. So in the example that we looked at, we use a dotted line for the grid lines. If you want to know more about a whole bunch of different other options that you have available to you corresponding to plotting in R, look at the help corresponding to the par function. Par stands for parameters in terms of graphics parameters. And if you look at the help for par, you get a long list of different things that you can do with your plots. Okay, so now I got this plot here. Let's say I want to get it into Word because maybe perhaps I am doing a project or some kind of assignment, and I need to turn this in. And so there are a number of different ways that you can get this into Word. So if I click on File, Copy to the clipboard as metafile, and I'll just come down here and hit Paste. And there's my plot. Now, unfortunately, with some newer versions of Word, you can see that we have a whole bunch of white space around the lower and right edges. I'm not for sure why this occurs now in Word. And so what you might have to do is actually do some cropping to make the plot look nicer. So there's some cropping right there. Okay. Other ways that you can work with these plotting or these plots is that you can actually save it as, let's say, a PDF. That can be very useful. If, let's say, if you're familiar with LaTeX or LIX, and you want to incorporate a plot from R into that. I use LIX a lot myself, and so you can simply import it via PDF like that. Okay, let's see. So that takes us to page 9. Now, a question that many students ask me is, well, do I have to use code when I'm using R? Aren't there like point and click methods? And the answer is yes to both. You do need to use code, at least for even an introductory course. The stuff that we're going to be doing is such that code is going to make it more flexible what we can accomplish. And so that's why we do need to use code. But there are also point and click ways to use R, and this can be very instructive, especially at the very beginning of learning how to use R. Now, generally, the most used of the point and click methods with R is R Commander. And this is actually a package that you will need to download to your computer, similar to what you've seen previously in the introduction to R notes. And to actually use it, you can type library. And this is actually how you invoke any package that you've downloaded. You say library, and then the name of the package, R Commander, or in other words, RCMDR, parentheses. And if I hit enter, R Commander will open up. Open up in a different window or a different monitor for me. And this is what it looks like. So the first thing that we can do with this is to open up a data set in it. And we've already looked at the GPA data set. So when I clicked on no active data set, we already have GPA. If I click OK, now it's ready to go. I can do view data, and you can see there's the data set itself. So we can do some simple numerical summaries. So if I do statistics summaries of my active data set, look what happens. I have the same output and same code that we've seen previously. So summary GPA, and we get like the mean, median, and so on. And so one of the nice things about R Commander is that it doesn't always, but it often uses the same functions that someone would normally use if they are using, if they're just doing the programming themselves. So to some respect, it helps you learn the actual programming code. Now, I will tell you that there are a number of functions that R Commander uses that I typically would not use myself. So, for example, if we go under graphs, let's see now, let's do a scatter plot. Again, this will open up in a different window. And let's say I want high school GPA on my x-axis, college GPA on my y-axis. And if I click OK, what will happen is, and again, it opened up in a different window. This particular plot's produced and looks very similar to the scatter plot that we had before from the plot function, but instead R Commander has its own function called scatter plot that actually did it instead. Now, R Commander can also be used, for example, In other ways, let's say if I want to find the probability that a standard normal random variable is less than 1.96. So I go under distributions, continuous distributions, normal distribution, and then normal probabilities. And I don't know why it keeps on opening up in a different monitor. And if I type 1.96 there, click OK, we have this 0.975 probability once again, and it comes about through the p-norm function that we've used previously. Okay. So some final notes here. This is on page 12. I'm sorry, page. Well, for some reason it shows page 13 here, but at least it was page 12 of my printed notes that I had before. I think I still have an old plot, that graphics plot that I copied and pasted in here. Okay, so some final notes. Now, one of the nice things about R versus a commercially available software package is that all the code that's used to do the calculations is available to you. So we've kind of seen this before. If I were to, let's say, to type the function SD, which calculates standard deviations, we can see the actual code that's used to calculate the standard deviation. And this is what's true for any other function out there. So as you become more advanced with using R, there will be times where you want to actually look inside the code for a function, see how the actual calculations are done. And that's always possible in R. A question that I often have students ask me is, how can I change where the tick marks are on a plot? And in other words, in our previous plot that we've seen, let's actually do that plot again. Instead of let's say high school GPA 0 to 4 by 1, maybe I could do something else. And the way that you can get that done is to use the access function. Actually, before you do that, you need to add a little argument in plot, XAXT, X axis T for tick, and then put an argument value of N for no. This tells R, hey, don't put any tick marks there at all. And we can then add those tick marks using the access function, where I say side equal 1. Now, how do I know 1 is the x-axis? Well, I look at the help corresponding to the axis function to see that indeed that's what's needed. Where do I want to put the tick marks? Well, how about a sequence of numbers from 0 to 4.5 by 0.5? Just to show you that indeed that is a sequence of numbers. How about if I just highlight that segment of code and run it? And we can see that indeed that it is. So if I run this set of code here and then bring up the plot once again, we can see now my x-axis tick marks have changed. Suppose I want some what are called minor tick marks also, meaning I want some tick marks between, let's say, 2 and 2.5. Then I can use the access function once again. But now instead of going by 0.5, I'm going to go by 0.1 with my SEQ, my sequence function. I want the height of the tick marks to be 0.01 relative to the numerical scale that R is using. And I don't want actually any kind of labels shown. So I don't want the actual numerical values. I just want the tick marks. So if I add that segment of code, and there we go. Those are my tick marks. And let me go to the end here of the notes. Okay, so to conclude here, there's a large, very large community of R users out there. And so because of that, there's many sources available on the web that you can use to get help. So you're not just necessarily limited to the help that's within R itself. So for example, there are a number of websites out there, such as Stack Overflow, where people ask questions and then corresponding and then others answer that corresponding question. Very frequently, if you do a web search where you type in, well, how do I do a plot in R? Often at the top of your search will be results from a place like Stack Overflow. There are a number of really useful blogs out there on R as well. An aggregator of these blogs is r-bloggers.com. And lastly, there are also listservs out there that are very useful too, where you can ask questions and get answers to them. So I just want to conclude with something that I wanted to mention at the very beginning, and that is all my R code that I was using, my data sets that I was using, they are available to you on my website. In all my examples that I use in my classes, I always have example, the name of the example, in this case GPA data. And then in parentheses, I'll have any tools that students can download to help them implement this particular example on their own computer. So in this particular case, GPA.R contains all my R code that I was using. GPA.txt is the actual text file that we read in. And also remember we did GPA.csv, which was our comma delimited file that we looked at as well. So sorry I didn't mention that at the very beginning. So that then concludes this segment of the Introduction to R.